thanks for being here today. We have Dr. Alireza Kasaiezadeh here to present. He's an associated research associate here at the University of Waterloo in the mechanical and mechatronic department. Where he received his PhD degree. He also has a bachelor and a master degrees from Sharif University of Technology, and more than 10 years experience in automotive industry, especially in active system and chassis system design. And he's here to talk about integrated active safety system in modern car.
Yeah.
Thank you for being here.
Thank you so much. Thank you so much for having me here. Today we are going to talk about the integrated active system, active safety system. But before we go to the integrated system, I'm going to talk about a little bit about the safety system, not very complicated one. At the end, I'm going to talk about the very recent result that we have in integrated active system, safety system. Yes. Yeah. Okay. Right. Yeah. Technically, the main reason that we are using this system is to reduce the number of fatalities and crashes that, of course, happens on the road. But we have three main components: vehicle, people, and traffic environment. And we should technically improve each of these three components. My focus is basically on vehicle improvement and adding some of these features that I'm going to talk about to the vehicle to improve the safety. Again, these three components have some interaction with each other, right? So for vehicle to people, we have some warning system that, again, is a part of our job, I guess. We developed some warning system to let the driver know what he should do in a critical situation. Again, there is another interaction between vehicle and traffic environment, V2V, V2I system that you have. I'm pretty much sure you know about them. Can help us to improve, again, the or decrease the number of fatalities that may happen. As I said, the main focus today is on adding or talking about the features that are available in the vehicles. In conventional car, safety features are called passive features or passive safety features. Many of them, we know them: seat belt, airbag, or maybe multiple airbag. These are the passive safety system. But to improve and again to decrease the number of fatalities, we definitely need to have active safety system. And active safety system start with ABS. Most of you are aware of it. But we have a whole bunch of active system that today I'm going to talk about. Before we start talking about this system, I guess I should clarify where this type of system are useful, right? Of course, after crash, right? Passive system can help after crash. Seatbelt, airbag, this kind of system can help when visible crash happens. But before that, near the crash or crash-relevant conflict, in those situations, active safety system can help us to prevent to enter the crash environment. The other point that I should mention here is when we are in near crash situation, usually the reaction time of driver is not fast enough to prevent the crashes, right? That's why we have this kind of system, and these are helpful to prevent the crash. So although experienced driver can help, but as I said, in this area, in this that's a very short period of time, right? In that time, even an experienced driver cannot prevent the crash in some situations. We have a bunch of active systems, active safety system. I have just a snapshot here. Again, if we look at the technically the crash situation, you can see when we are in accident avoidance, close to related to that crash conflict or near crash event situations, we can divide the whole system based on this graph. We have active safety system in here, dynamic limit control like ABS, TRC, TCS, B.Sc. I'm going to talk about this system and let you know what are this abbreviation stand for. We have integrated control system. Again, you can see where these are helpful, right? Active system, active safety system is mostly talking about this area of the feature that we have in the car. Again, if I go back to the previous slide, warning system usually helps in at-risk behavior, right? In this situation, still we have enough time to let the driver know what he should do, right? And then just some information can help the driver to prevent that. This area, the very first part, driver visibility assistant or driver assistant features are the one that help in at-risk situations. Okay, so now we have to categorize the whole active system, active safety system that we have in the car. We have different subsystems in conventional car, and we improve them, add some feature to this subsystem to make them work as an active system, active safety system. Brake system, steering system, suspension system, and powertrain and transmission are those subsystems that can help us, and we can add some feature to them to basically have active safety features. Now let's start with braking system. We have some active safety systems that are working based on braking subsystem, and now I'm going to talk about those. Again, you can see we have this whole bunch of active safety systems based on braking subsystem. It started with ABS that most of us know, but we have again a huge range of active safety systems that are working based on brake subsystem. Okay, so you might say, okay, we are interested to know how this system are working, right? I guess today is the best day to see why this system is are helpful, right? I have a very helpful graph here. I'm going to redraw it here because most of the discussion will be based on this. One of the main components in a vehicle is tire. Let's say I'm going to talk about the longitudinal force, and we have something that is called a slip ratio. A slip ratio is defined here, right? That's technically a ratio of the relative velocity between your wheel velocity and vehicle velocity over the vehicle velocity. The numerator is the most important part of it. And what it means is, assume that you have a solid cylinder, right? It has a pure rolling on the surface, right? In this case, when it's completely solid, right? And we have a complete rolling of this solid cylinder, this relative velocity is 0, right? There is no skidding between the surface of the cylinder and the ground, right? Okay, but what happens is when you have a flexible tire or flexible cylinder, right? In that situation, once you apply force or torque over it, right, it starts with a little bit of deflection, right? So in that case, whenever you apply a force, you will have a relative velocity, right? So as long as you have a force on the tire, that relative velocity is not 0 anymore because it's a flexible component, right? So now if I'm going to look at the force generated at contact patch here, it usually behaves like this. Whatever slip ratio you have, you can look at the force and it gives you the force that you have, right? Usually it's somewhere between 0.1 to 0.2. Your peak force is usually there.
So this force is frictional force you're talking about?
If you want to compare it with Coulomb friction, right? Let me show the Coulomb friction behavior of this. You can easily see what is the relationship between Coulomb friction of a solid part and the tire, right? What happens if I have this solid part here and apply a force to it, right? I apply a force, increase the force, it goes up, right? I increase the force, and at some point it just drops and then increases, right? Up to here is a static force, right? It's we call it Fs, right? And then it drops to the pneumatic friction, right? What happens is, because it's flexible component, this one is a little bit shrink, right? If you compare this one with flexible part, you just shrink it because it's flexible. So the first part of it is related to the deflection, the complexity, the flexibility of the tire, and the other part is like a skidding, right? That's how it works. But if you want to generate the maximum possible force at contact patch, what you should do is to always keep the tire at this point, in this region, right? If you want to have a smaller force, that's fine. You don't apply torque to it. But if you want to have the maximum force, you should keep the tire condition in this region. That gives you the maximum force, right? And now you can easily see how ABS is working. Before we go to that part, we have the same behavior for lateral force, right? We have the same behavior, but this one is not a slip ratio, it's called a slip angle, right? The slip angle is if this is your tire before deflection and you apply it lateral force to it, it deflects. I'm just exaggerating the deflection, right? Not like that. But this is your slip angle, right? The angle that you define between the tire plane, right, and the deflected one. So again, you have almost the same behavior, right? That's the whole idea that we are using in most of the active safety system. Okay, so what happens is when you are using ABS, very first active safety system that we talked about, and the driver slam on the brake pedal, right? What happens is driver doesn't have any idea of where we are in terms of the slip ratio, right? We just need the maximum force to stop the car, right? But if we don't have ABS, what happens is because it applies a very harsh force on it, it goes up and all the way goes to the other one. In this area, when we are close to one, that's the one that we call wheel is locked. Have you seen the wheel is locked? when it locks, it stop rotating, right? Just lock, right? This part is when the wheel is locked. ABS, anti-lock brake system, is the one that prevents this situation. It always have a hydraulic modulation that technically keep the tire or the whole wheel dynamic about this region, right? So what happens is it always generates the maximum possible force, right? But it doesn't mean that you are safe as long as you have ABS, because if I draw this curve for ice or snow, you see that we have this curve, right? If this one is for a dry road, right, and this one is for ice or snow, it's significantly less than what we have. The maximum force is significantly less than what we have on dry roads. What happens is when you have ABS, all it does is it compensates for this much difference, right? So doesn't mean having ABS doesn't mean that we are safe. All we do is just save this much force.
Does the slip ratio has a sign? I mean, it's positive, negative. Does that make it?
Yeah, depends on how you define it, but based on that definition, if you want to show it, it has a negative side as well. So you can have the negative sign for braking, positive sign for traction. And now I have, can you see this dashed lines? This dashed line shows the lateral force when you have longitudinal slip ratio. So what it means is, if you are using the whole capacity of tire in longitudinal mode, right? Let's say you're braking very harsh, right? Or you're accelerating very harsh, right? In those cases, you are increasing the slip ratio, and at the same time, your lateral force drops as well, right? So what it means is your tire rod capacity is limited. If you use your capacity, your tire capacity in longitudinal mode, your lateral capacity drops, right? So what it means is if we can save, or we can help the wheel to stay in this safe zone, right? Still we can save the lateral force as well, right? So having ABS not only helps us in longitudinal behavior of the vehicle, it also helps in lateral mode. Why? Because of these curves. These are the lateral forces, right? So now now you can see what happens when you have ABS in your car and you are in a sharp turn. When you have ABS, it can help you to stay on the track. But when you don't have it, maybe it becomes unstable and lose the path.
Practically, in all models, in all makes, I think we have ABS.
Right now, it's mandatory. Even ESP, I haven't talked about it yet, but ESP, the next generation of this active system, is mandatory since 2012 on North American car, right? Okay, so in here you can see ABS can help even in longitudinal mode. Okay, so the way that it works is because it started, as I said, in 1970, right? In those days, we didn't have enough sensory system, right? And even a computational power to see what the situation is. In those days, all we had was a wheel sensor that shows the wheel velocity, right? And the conventional ABS, very old versions, it just works based on wheel acceleration, right? There is no other sensory system. And what it does is once it sees the wheel acceleration is too much, it's figured that out, it's passing the peak. And what it does is it has a hydraulic modulation. It just starts some pulsation, and it brings the force back, right? It just drops a little bit of force, brings the slip ratio back, and once it's at the good situation, it stops, right? That's what you feel when you brake on ice. You see it start doing this, right? That's how ABS is working. Okay, the other, so we can talk about the next generation of this active system that are working based on brake system. Another safety feature is electronic brake distribution, EBD. Maybe you have seen it in, if you want to buy a car, probably you see this feature in
Actually, interestingly, I didn't do the topic detail. I bought a new congestor, REV4 2014. So yeah, they were telling that they
It has EBD?
Yeah, they included.
Okay, good.
When I was discussing with the service.
Okay, so you should be able to
And
see
TCS,
how
they included TCS as well.
TCS as well. Okay, so these three features are now very standard feature in the car, right? What EBD means is what I draw here is the longitudinal force based on slip, right? But we have a set of curves when you have different normal loading on each tire, right? So the bigger normal force that you have on each tire, your tire capacity increases, right? So let's say if you, and probably you can see what I mean. Heavier cars are better in terms of stability in this fashion, right? If you have a small car, probably you see most of the time it's skidding, right, on ice, right? So that's what happened in tire model, right? But what EBD is doing is when you brake, we call it dive mode. What happens is we have a load transfer to the front wheel, right? So what happens is your rear wheel, the normal force on rear wheel drops, right? So the capacity of the tire, the maximum force that you can generate on rear wheel drops, right? In those situations, particularly if you are in a turn, if you lose the control over the rear wheel, it start spinning, the car starts spinning about the z-axis, right, the normal axis. So it can cause some instability in the vehicle, right? So what EBD is doing is, it's looking at the condition, right? If you are braking harsh, what it means that your tire capacity on rear axle is not the same as before, right? So if you ask extra forces on rear axle, what happens? You go to the unstable region. You pass this peak, right? That's what happened in even normal car, as I said. If you brake very harsh, you go to this unstable region, right? And you use the control over the wheel. That's what happened on rear axis now, because your normal force drops, your tire capacity drops, and now the rear tire doesn't have enough capacity to generate lateral force or longitudinal force, right? So it becomes unstable. What it does is ABD is looking at the situations, and once it sees there is a huge load transfer, it changes the distribution of the braking forces, right? Even in conventional car that we do not have ABD system, we have some passive component, these two components, that are sensitive to the longitudinal acceleration and does almost the same thing. It drops the force in those cases, right? But it's not an optimal distribution, right? EBD, what EBD is doing is technically, if you write the equation of motion, we have an optimal distribution. The conventional system, because they're passive, right? There is no way to change that ratio. Conventional system have this feature to drop the force, but it's not close to the optimal distribution. What it does, what EBD is doing, is using ABS module to change the force distribution such that you are close enough to the optimal distribution of the force, right? That's how EBD is working. And as a result, you can compare the stopping distance of different car. The one that has EBD should work better. You should have a smaller stopping distance. The same way working in when you are turning. As I said, if you add extra force on real axle, you lose, you go to the unstable region, you have bigger slip ratio, and if you remember for lateral forces, if you have bigger slip ratio, your lateral force drops, and then you cannot stay on the path. You lose the stability of the vehicle, right? So it's still, even this one, even if you control the brake system, that it seems brake system is always working longitudinal mode, but it's not, right? It's helping in lateral motion as well. Okay, let me just skip this part, the way that these systems are working. Another safety feature that we have on not very conventional one, right, is called HPA, which technically sometimes when this usually happens for inexperienced driver, when they see there is an obstacle on the road, right, they are panic, right? They cannot push the brake pedal as it should be, right? And then what happens is you have a delay, right? If you are a good driver, you can generate that much force. But if we are panicked, we cannot generate that much force, and then it might result in, see, the stopping distance for a system without B.Sc system is 73, right? So what happens is, if you have this feature on your system, as long as it sees there is a harsh case, right? There is a emergency case, it generates the torque that is required, the same way that a good drivers do, right? So it can help and reduce the stopping distance. We have some other features for, particularly if you have a manual car. We call it heel hold control, or the other one, heel distance control, where you're driving down the hill. These are not as important as the other one. Let me talk about this one, CDD, or control deceleration for driver. CDD system is a good application for a connected vehicle, right? What it does is, when you have a communication between car, and for some reason driver forget to brake, or for any reason, right? Maybe distracted, drunk, or whatever, right? Once it sees there is another car in front, it brakes automatically without any commands from driver. You can define the distance, the threshold for this distance, and then it stops by itself.
Is it common now, or?
No, not that. No. As I said, you have to have a connected vehicle, right? You can use almost the same feature, right? In terms of physical system, is exactly the same. The algorithm is a little bit different in intersections, right? Sometimes there is a car coming, right, and you cannot see it. You want to cross the cross section, right? And then because you have a connected system, it stops, right? It doesn't let you pass the intersections.
Okay, in this district they have lane changing a lot. Like you are changing lane, but you have a car, your blind spot, if people put it, he will give you a lot.
Yeah, I know what you mean.
Same thing.
Yeah. This one is not just alarming, right? It's not just
it's
warning.
working.
It breaks, right? In terms of communication, maybe it works the same way, but this one breaks by itself. It's just in emergency cases.
It is same as some new Toyota cars use in adaptive cruise control when they use radar to stop
Yep.
the car. But they are not connected vehicles.
Again, depends on how you define connected vehicle, right? If you're talking about infrastructure that all of the car are connected to the infrastructure and the other cars, you can use the same vehicle, right? You can use ultrasound sensor to detect where the other car is, right?
I think for some of the Volvo cars, it has active system to prevent the car from hitting some pedestrians, right? It's when the car speed is I think it's below 30 kilometers per hour, then it can automatically apply the steering pedal to stop the car. Or if the car sees there are some obstacles in a wall in front of the car, and still the speed is not too high, it would also apply the brake automatically to stop the car. But probably when the speed is high, it will disable the system for some reason. It's no need to be connected with.
Yeah, I know what you mean, but the main difficulty to implement this kind of features is defining those thresholds, right? And I guess this type of discussion usually goes to the autonomous type of vehicle, right? And that's the next generation. Yeah, they have to solve this kind of problem, right? In terms of physical system and the way that it works, it's now achieved, right? We know how to stop the car, but how the algorithm should be working, it goes to the other part, right? I know, yeah. Okay. Again, we have some other features we can talk about it if you are interested, but I'm gonna skip this part and talk about yeah, I guess I can talk about a little bit about the brake by wire. Have you heard about it? Brake, see, in regular convention, regular car, what the brake system is doing is you have your brake, you have a booster. I delete the slide that has the whole brake system. But the main feature is we have a piping system, hydraulic system, right, that generate a pressure and it goes to the caliper in brake system, and once the driver asks for braking, it increases the brake, the oil pressure, and then the caliper, just like a hydraulic actuator, it grabs the disc and it stops the car, right? So the connection between pedal, what I mean is the connection between the brake pedal and the wheel is that hydraulic line that you have, right? But in brake by wire system, we remove those parts after. So once you brake, it just generates an electric signal, right? And then you send this to ECU, or ECU is your electronic controller, right? You send this signal to that controller, and it decides how to distribute and how to brake at each corner, right? In terms of reliability, they are working on it to make it more reliable, but in terms of reliability, that was the main difficulty for this kind of systems. Right now, it's reliable enough as the way the other systems are. But the advantage of this system is if you have this kind of system, you can brake individually at each corner, right? So in conventional car, you have just, all you do is you brake, you increase the pressure, and the distribution, even if you don't have an EBD system, the distribution is fixed, distribution of the brake force, right? Even if you have EBD system, all it does is just change the distribution of the front to the rear one, not individual corners, right? So I discuss about this one. You can use brake-by-wire system for conventional purpose, right? No control, just a passive system. But next step, I'm going to talk about some systems that if you have an individual control on each corner, it can help a lot. Yeah, the other one is TCS system. This one usually works when you are in traction mode, in acceleration. Maybe you have seen, particularly if you have front wheel drive cars, when you want to climb a hill on ice, you might have some problem. And probably you can now tell me what happens. What happens is when you are on here, you have a load transfer to the back, right? So the front wheel has less normal force, less capacity, but the whole traction goes to the front wheel, right? So that you might see, okay, the wheel starts spinning because on that wheel you pass the peak and then you lose the control. So what TCS is doing is it's doing almost the same algorithm like ABS, but in traction mode, right? So it doesn't let you pass this peak. You keep it always here. But in terms of the physical system, the way that it works, it's a little bit different. Sometimes they use brake system to drop the acceleration. Sometimes they are using, they drop the throttle in your engine, right? Or even sometimes they change the timing of the engine, right? So in terms of physical system, the way that TCS is working, we have a whole range of systems, right? But in terms of wheel dynamic, they are doing the same things. They do not let you pass this peak, right? That's how TCS is working. So TCS is like ABS, but in traction acceleration mode. Yeah, these are the differences in features. Okay. So before we go ahead, I'm going to talk about a little bit about vehicle dynamic when we are turning, right? Again, I'm pretty much sure you have seen this behavior. Sometimes, again, this may happen. You may feel this one when you are driving on ice or snow. Sometimes your expectation from dry road, right, is when you turn the steering wheel angle, let's say 20 degrees, your feeling is your vehicle should move this way, right? But once you are on ice, it doesn't obey what you are asking. It just keeps going, right? When it needs more steering to keep on the track, it's called understeer, right? It doesn't obey whatever you ask. The other one, which is more dangerous, is when the vehicle is oversteer. That's what we want, but it magnifies whatever you ask, and then it starts spinning, right? It becomes totally unstable, right? Both of these situations are not acceptable. This one is more dangerous, right? So when we design a car, usually we design, and this, the ideal one is called neutral steer, right? What happens is when you increase the velocity of the car, the way that the vehicle dynamic works is it usually tends toward the oversteer behavior, right? you design it, let's say, for 50 kilometer to be a neutral steer. But once you increase it to 150, it becomes oversteer, right? So the way that passive systems are designed is we design them a little bit understeer, such that once you are in critical situation, higher speeds, it becomes neutral, not oversteer, right? As I said, this one is more dangerous because if your vehicle is understeer, you can steer more, right? But this one magnifies whatever you apply and then becomes unstable. Okay, so you just have these two in your mind, and then I'm going to talk about another system. As I said, this feature is now mandatory in North American car, ESP, right? The way that it works is you can define your desired behavior just like the neutral steer, right? But there is a control, a supervision over that, right? And it all depends upon what the situation is. It always helps you to stay close to the neutral steer, the desired behavior, right? I'm going to talk about how this one works, but just look at this time. That's the reaction time of the system, right? And that's why even an experienced driver cannot save the car in very harsh scenario, right? That's very fast, right? It's very difficult to react that way. Even if the driver reacts that fast, maybe the vehicle, because the vehicle by itself has a delay, right? It takes time to see whatever the driver applies, right? So we need a faster reaction. And now let's see how this one is working. In general, if your vehicle is understeer, it helps to be close to neutral steer, to the desired behavior. If you are oversteer, right, so you lose the path, you magnify whatever the driver is asking, and then ESP can help to remain on the path. But let's see how this system is working. Remember I said if we have control over each individual corner, the brake system, we can gain a lot. Now let's see how this one is working. Let's say your vehicle is oversteer, right? What it means is if I turn very sharp, it's gonna magnify my command and becomes unstable, start spinning, right? But how this ESP system is working is it looks at the situation and compare your actual behavior with the desired behavior, and if it sees you are going to be oversteer, it activates this wheel, brake on this wheel, this side, right? So if you write the equation of motion about the CG, the center of gravity, what happens is this brakes is this individual. You are not braking on all the wheels, right? Just this particular course, right? So if you brake at this one, you apply moments to bring it back to the desired behavior, right? Now, even if you are having an understeer behavior in your car, so your desired path is this one, but it doesn't obey whatever you want, right? So what it does is it activates the other side, the brake system on the other side, and apply torque such that this behavior modified to the desired one.
Question is, how does the car know where I desire to head it to? How does the car know I'm understeering or oversteering?
Okay, that's a good question. We have a sensory system. That sensory system, the main one for this particular one is called IMU. IMU sensor gives us the acceleration. We have different version of it. The very basic one has, we call it as 3-axis IMU. 3-axis IMU gives you longitudinal acceleration, lateral acceleration, and yaw rates, right? rotational velocity of the vehicle about the normal. That yaw sensor, right? That yaw sensor shows where you are going. And at the same time, you have your steering wheel angle. You can have a simple model. And based on that simple model, if you fit that steering wheel angle that driver is asking for, right? If you fit that one to your simple model, your system simple model gives you the desired response, right? You have the desired one, you have the actual response, and you know where you are, right? Based on that, you can activate each individual core. That's how it works. Exactly what I just said. You have the steering wheel angle, you have your simple model, you can define your desired response, and at the same time you have your sensory system, yaw rate sensor, see what the actual behavior is, compare these two. Most of the time there is a discrepancy between these two, but if it's small enough, we just ignore it, right? But if it's large enough, we activate the ESP system, and then it compensates for that error. That's how it works. But in ESP system, as I said here, the main problem is in this system, they are not smooth, right? They do not react until you are in the critical situation, right? They do not react as long as you have a small error, right? And once they becomes activated, you feel like a jerk, right? You see that. The same way that ABS is doing, right? Sometimes drivers feel bad when they start doing this, right?
So I didn't get that concept. Desired vehicle behavior. So that car learn from the driver how he drives regularly.
No.
That thing,
No.
or it's a pre-loaded.
Yeah, it's a predefined behavior, right? It's not based on, I know what you were saying. That's
Not adaptive.
no, it's not an intelligent behavior, right? You know what type of car you have. You know what the mass, the moment of inertia of the car when you're designing it, right? Based on even you know what the tire you're using is, right? So you can define your desired behavior just a solid model, right? You don't change it over the time. Okay, so that's how ABS is working, and now these are all based on brake system, right? We have another set of active safety systems that are working based on steering. So if we want to, the same way that we look at the brake system, right? We have conventional brake system working based on hydraulic, and then they evolved to the brake-wire system, right? We have the same behavior in evolution of a steering system, starting with rack and pinion steering system. Still, we have this type of steering system in most of the car, but we have equipped them with some assistant, right? Hydraulic assistant, right? Hopefully, this didn't happen for you, but sometimes when your steering assistant system fails, you feel it's very hard to steer, right? So for assistant, we have happened. Hopefully not. For assistant, we have hydraulic assisted system or electric assisted system, right? This one is using a electric motor to help you to steer, right? So the heavier car you have, the more help you need to steer, right? And now the last version of this system is a steering by wire system, right? In all of the system, you have a mechanical linkage between your steering column, right, and your wheel when you are steering. But in this particular one, there is no mechanical connection. Again, once you steer, it just becomes an electric signal. It goes to your ECU, and then you have independent maybe, or you might have still that rack and pinion, or you can have independent steering on each side. right? That's how it works. Again, reliability is an issue. We are working on it because it has some advantages if they can come up with a solution to mitigate that reliability issues. But can you tell me one of the difficulty that we might have for this one? Let's say, remember I said when you have the power assisted system, they are looking at the way that you are steering, right? And they just help you to steer easier, right? But at this, although it's helping you, you have a feeling of a steering, right? You know, if you want to steer more, you have to apply more force to steer, right? But in that steer by wire system, one of the difficulty is it's just a wheel, right? You can turn it without any feedback, right? So one of the features for that one is they have to have electric motor here to generate that feeling for you. It's just a fake reaction, right? Just to give you an idea on how much steer you apply, right? You don't need it, but because most of the driver have this kind of feeling, it might be dangerous, right? If you don't know how much to steer, you might, right? So that's why we have this steer, that electric motor over there. But anyhow, yeah, sure.
What's the advantage of separating these two systems from separating the wheel from the steering wheel?
Again, many advantages. One is you can make it lighter. See, between this one and this one is much lighter, and this one, mechanical components have weight. Right? That's just one advantage. If you can steer individually at each corner, right, you can have an optimal. The same way that you brake optimally, right? We discuss it in EBD system. You can steer individually at each corner and have an optimal solution. Yeah, in integrated system. After that, I'm going to talk about the integrated system. That definitely is a solution for that. And again, these are different generation of those. I'm not going to go with those. We have one more feature, which is a four-wheel steering system. Again, you might see this one. All-wheel steering. We have all-wheel drive, which means all the wheels are in traction mode, right? You can drive them, right? With this one is all-wheel steering or four-wheel steering, right? That's a little it's different from what you see. That one is called four or this one or all-wheel drive. That's what you might see the sign behind the cars, right? But this one is it's not on. No. That's the steering, right? The other one is just traction. This is more common. This one is not, right? So the way that it works is technically in low speed, right? In low speed, we need more steering effort, like when you are parking, right? You need more power to apply, right? In those cases, you are not, your main concern is not the stability of the vehicle when you're driving in 30 kilometers per hour, right? The stability is not concerned. The minimum turning radius is the main concern, right? How big the area should be to make it turn, right? In those situations, if your rear axle has a steering opposite to your actual steering in the front, it helps you to have a smaller turning radius, right? And you can see why it works, right? If you have a steering in this one, your center of rotation becomes somewhere here, right? Compared to the one if you have a straight one. It goes here, right? The minimum turning radius decreases from this one to this. But you can turn easier because your stability is not the main concern. But in higher speed, in which your car might be oversteer, right? So the stability is the concern. If you steer the same way that your front steer is doing, right? Your vehicle becomes kind of understeer. If you steer the same way that you're steering on front axle, the same way, it works opposite way, right? It's kind of bring you back, make your vehicle understeer. So this one can help to increase the stability of the vehicle in higher speed, right? So we can take the advantage of both. Higher speed you can steer, if you are able to steer on the real axle, you can increase the stability in higher speed and have a smaller minimum turning radius in lower speed. But again, in this situation, it's not. This one is going to left. Left of you, right?
The first one is making left hand for sure.
Both are
Making left hand.
both of them are making left hand. Right? The only difference is this one, because your rear axle is steering the same way as front one, steering is a little bit harder. And this helps in higher speeds. Right, so up to here, all the steering system that we talked about are passive, right? There is no controller to monitor the vehicle behavior. But if we have those, particularly those brake wire system, we can control the lateral behavior of the car the same way that ABS is doing. Let's look at the tire behavior again. As I said, the front, the lateral force based on the slip angle, and you remember what that slip angle is, right? The sharper turn that you make, the higher slip angle that you have on tire, right? Because when you turn sharper, you ask for extra or bigger lateral force, and that's bigger lateral force generates more slip angle, right? But there is again a limit here. If you ask for extra force, you might pass the peak, and then the force drops. The bad things in lateral force is, if you compare it with longitudinal one, when you pass this peak, this minimum value is somewhere between 70 to 80% of the maximum force, right? So you still, although you lock the wheel or the wheel is spinning, but still you have 70 to 80% of the maximum force. But for lateral one, it's not the case. It drops significantly, right? And then what happens is, again, this happens on icy roads, very close to zero. So if you're driving on ice, right, and then turn very sharp, you pass this peak, and your lateral force drops. Technically, there is no way to stay on the path, right? So when you are turning, right, you need, if you want to stay on the path, you need to generate a lateral force. There is no way, right? That's the second Newton law. You have to have a lateral force if you want to turn, right? So if you lose the lateral force on the front tire, particularly on front tire. There is no lateral force here. Technically means you lose your steering. There is no control over steering, right? If you turn very sharp, you feel there is no steering. You turn it, but it really doesn't do anything, right? So this active steering system that we usually have it in front steering because we have a steering in front suspension usually. The way that it works is once it feels your steering angle is large, it brings it back. So you steer a lot, right? And it compensates a little bit, brings it back, right? But you might say there is something weird here, right? You steer this much, but the vehicle by itself says that's too much, don't steer that much, take it back. That's why it's not that much common in the car, right? It's override the driver. They are smart enough such that it brings it back to the normal force, right? The maximum force. It doesn't do anything bad, but the feeling is not good, right? Because your expectation is to turn, but it doesn't. That's the bad part of it. But again, it depends on driver, right? It's not very common just because it's override the driver. Now let's talk about the integrated system. How much time do we have? Okay. So in general, we talked about brake system, traction, the steering, right? But if each of them are working individually, that's fine. But you cannot take the advantage of the whole system that you have, right? Let's look at that ABS system that we talked about, the ESP system, right? I said if your desired path is this one and the actual one is not the one that you want, right? It just activates one corner to bring it back, to generate a torque that brings it back to the desired response, right? So why didn't you ask me why just one? Why not to ask other wheels to generate the torque and increase or generate the desired torque to bring it back? And then, what if we don't? Why we should not combine the active steering system? Because this one can help us the same way that ESP is doing, right? If your system is oversteered, why not to just adjust the steering? That's one solution, right? You can apply the torque, brake torque, to bring it back, but still you can apply the steering to bring it back. That's much easier, right? And why not to apply positive torque? Why we always have to brake? We can apply positive torque in some case. Physically, it's not as easy as braking, right? But in general, if we have this capability, why not to use it, right? So if we want to talk about the general case, we have 12 actuators in general. We have 3 actuators at each corner, right? The steering system, maybe more, if you want to distinguish between traction and braking. You have traction, you have braking, you have a steering, and also you can change the normal force, right? Normal force was important too. Remember EBD, what EBD is doing, right? EBD is changing the force distribution, but it's working based on normal force, right? It's sensitive to the normal force. So if we have active suspension, right? If you can change the normal force of each tire, why not to use that one as well? Right? So we have in general, let's say, 4 different actuators, 4 corners, 16, right? Braking, steering, traction, and suspension. And then your body motion has 6 degrees of freedom, right? That's how a solid part is moving in general, right? So we have 6 degrees of freedom for body, and we have 16 actuators. So how do you want to distribute force and torque between these actuators? That's an optimization problem, right? That's what integrated vehicle dynamic system means. Means you have all of these actuators, or you have some of them, a combination of this, and you want to have optimal solution to get the best response, right? Obviously, when the problem is an optimization, you can decrease the amount of energy that you want to use. You have many other constraints, right?
Why can you use pitch and roll?
Pitch and roll?
What kind of situations?
Okay, so your question is why these two are important, right?
Yeah.
Okay. Roll is definitely very important, right? Because if you don't control it, usually in passenger car, compact car, if you roll more than 5 degrees, after that you don't roll, you just roll over, right? That's very dangerous, right? So we usually use active suspension to prevent the rollover. That's why we use. That's why the roll motion is important. If you say why pitch is important, usually pitch is not important in terms of stability, but it's important in terms of ride comfort. Right? Your feeling when the car is doing this is not pleasant, right? And even they have shown that people are more sensitive to pitch motion compared to the vertical acceleration, right? Okay, so if we want to have an overall structure, the way that it works is still we should have the driver inputs, steering, different pedals, brake or gas pedal, and we send this information to a unit that is called driver command interpreter. We're going to generate the desired responses, right? Remember ESP, we have to have a desired response, we have to have the actual response. For desired response, we use this module. That's usually a model, a simple model that generates the desired response, right? So we have the desired response, and using sensory system, we can have the actual behavior of the vehicle, right? And compare this to send it to the control system. Control system is that optimization algorithm that we talked about. Depend upon where we are in terms of the error between desired and actual one, the system should decide how much torque or how much force we need to have in each of those actuators, including braking system, traction system, suspension system, and also the steering system, right? And then we apply those input to the vehicle, and if it works fine, we are on the track, right? We are following the desired path. That's how the control system is working. As now, let's look at a project that we have done here in Waterloo. It's a joint project with General Motors. Hopefully it works. Yeah. This one is when this control system is off. See what happens. The maneuver is a slalom maneuver. That's the no, that's off. It has the system, but it's off, right? And now, when we have it on, yeah, I was there.
The standard is that.
There we go. And here you can make making it reliable, right? And remember, this one is on dry road, right? On ice, that's totally different. You can make the car unstable very easy. Yeah, that's what we have. Yeah. Thank you so much. Any question?
We did lot of questions.
Okay.
Normally we don't do it questions, but professors are present.
This is really interesting. Thank you so much.
Yeah, they
You're
do,
welcome.
yeah.